Okay, today we're talking about angle addition postulates and angle bisectors and how we make algebra out of those two things. Okay, so notice here on the left, this is an angle addition postulate problem because we know the total of your largest angle. So this is angle ABC, right? That is the angle that we have there, and you know that the two smaller angles, namely in this case ABD, right? So here's ABD, and then we have DBC, this one. Those two smaller angles add up to give you the entire length of your largest angle. Okay, so that's the segment or the angle addition postulate. We can add up smaller angles and they equal the bigger one. Okay, now over here we have the angle bisector, right? So you have to be told in the problem that your angle is being bisected. So we're going to look for that vocabulary word, right? What does a bisector do? It cuts it into two equal parts. Okay, so if we know that XY, or ray XY, is a bisector, that means we know it cuts your angle into two equal parts. Okay, measures are equal, angles are congruent. So notice the difference. Measures has a little m by it and it's talking about degrees. The degree of this angle equals the degree of that one. Where down here we don't have the measure, we're talking about the pictures, right? The pictures are the exact same if we have congruent angles. Okay, so that's the basic theory of it all. You either are adding up two smaller angles to a total, or you are setting the two parts equal to each other. So let's see what that looks like when we do some problems with this kind of stuff. So here are three problems from your notes. So let's read and see what we can figure out here. We know that angle ABC is 84 degrees. Okay, so ABC is the largest of your angles here. Yes, this is angle ABC. And we know that it is 84 degrees. So we're going to put a big arc over everything saying 84 degrees. Okay, that lets us know that the whole entire thing is 84. So now let's put in your values for your other angles. Okay, I have angle ABD is 2x plus 8. So we're going to write 2x plus 8 in the interior of our angle there, right? 2x plus 8. That is from A to B to D. And then we also know that DBC is 4x minus 2. So we're going to write that in here in the DBC angle, right? So here's DBC. And here is angle ABD. Right? These are adjacent angles. They share this ray. Another vocabulary word. Okay, so you should be pretty convinced maybe that this is an angle addition postulate problem. Because if we take our angle ABD and we add it to DBC, we get the total measure of your angle 84. Okay, so algebraically that would look like 2x plus 8 plus 4x minus 2 equals 84. Right, let's scoot over. $84. So now we have our algebra that we need to solve, and we'll solve it for x. Okay, like we're asked to do. So take a moment, pause the video, solve for x. So we should be getting that x equals 13 when you solve this equation that you have created. So now we have to answer our last question. What is the measure of angle A to B to D? Okay, so we're only concerned about this yellow angle, the angle that I called here yellow. Only this one, ABD. So if we know x is 13, we're going to replace x with, well, 13. So 2 times 13 is 26. 26 plus 8 is 34 degrees. So our x value for our problem is 13, and the measure of this angle is 34. And I know we're not asked for it, but the measure of this angle down here would be 50, because these two have to add up to 84. But that's just a bonus. Okay, so let's look at number 2 and see if we see any vocabulary words. And how is this number 2 different from number 1? Okay, first of all, we see a vocabulary word, bisect. And what does it mean to bisect? Cut into two equal parts, right? In equal. So halves means equal. So this part here is equal to that part there. So we know that angle ABC, right, this large angle here, the largest angle, I guess, is 108. So we're going to put a big arc over everything with 108 degrees right there. Okay. We also know that ABD is 5x minus 6 degrees. So that is just this one, 5x minus 6. Okay, so there are two ways that we can algebraically solve this problem. Okay, one way is, of course, to know that because we got bisected, this 5x minus 6 also goes with this angle down here, right? Because they're the same. Bisectors make two equal angles. So we could have 2, if you want to, 2 5x minus 6's equals what? 108, right? Two of these same angles, because these angles are the same. We have two of them, right? You could write 5x minus 6 plus 5x minus 6 equals 108. Mathematically, that's the same thing. Or we can do 2 times 5x minus 6 equals 108. Okay. Similarly, we know that because this is a bisector and the whole thing is 108, then each of these angle measures are 54 degrees. Because it got cut in half, right? And half of 108 is 54. So that means we can make an equation with just this much. 5x minus 6 equals 54. Now both of these are correct, and x is the same value no matter what. As long as you do your math correctly, you get the same value of x. So you can use whatever problem solving technique you want on these ones, as long as you show me the work, so that I know that you did it correctly, geometrically speaking. And since we're asked to solve for x, I solved the blue equation by adding 6 and dividing both sides by 5. Or you could solve the yellow one. Either way, you should get 12 for x. Okay, so with a bisector, you know it gets cut in half. So you can either set it equal to half or make an entire equation out of it. Okay, so let's deal with this last one here. Here we have to draw your own picture, right? We don't have a picture to begin with, so we're going to practice your art skills, your geometric art skills, and draw this one. So what is the name of our big angle? TOP, right? So we're going to draw an obtuse angle, because we don't know if it's acute or obtuse yet, but our math will tell us. And we don't know what's going on, so let's draw it large so that we have space to write. Okay, so we have the point T, and then O is at your vertex, because O is in the middle. And then we have P to the right. Or you can reverse those. It doesn't really matter if you spell tot or top. And now we have to put in OR. Okay, so where are we going to find OR? Right down the middle. So please try your best to draw it exactly down the middle so that your eyeballs believe your brain when we do this, right? And a bisector means that this much is equal to that much. Okay, so put those little arcs in there also, because that is a visual reminder that these two things are equal. So now we're going to put in your values. TOR is 7x minus 9. That goes over here, 7x minus 9. And the other one is ROP is 6x plus 4. Okay, now notice we're not given any large angle, right? We don't know the measure of the entire angle, so we can't use the segment addition postulate to do this. Nor can we break it into two halves, because we don't know the measure of the whole angle again. But there is algebra that we can do. And what is that we're going to? Set them equal, right? Both of these equations are, rather, both of these angles are equal to each other, because this is an angle that got bisected. It got chopped in half. Okay, so now we need to do the algebra. So pause the video and do the algebra. Okay, so we're getting x equals 13, but we're not done. It wants the measure of angle top. So remember, that's the largest angle here. So we're going to take 13 and plug it back in for x. Okay, and when we do that, 7 times 13 minus 9 is 82 degrees. And because it got bisected, we know this one is also 82 degrees, right? We don't have to plug it back in there. But 82 plus 82 is 164 degrees. So the measure of angle TOP is 164 degrees. Okay, so remember, if you don't know a total, you can't use the segment addition postulate. You have to do basically a bisector and set the things equal. Okay? So in addition to that, we have two extra problems on here about midpoints. So let me show you those. So here we have two questions from your notes. M is the midpoint of AB. We know point A is at 1, 3, so let's use this grid right here and plot this. So 1, 3 is right in there. So there's point A at 1, 3. And then we have point B. No, we don't. We have point M at 4, 10. Right? Point M, the midpoint. We know that where the middle is right here at 4, 10. Right? That's a 10. So the segment we're looking for is this segment that goes from A through M, somewhere up here to B, but we don't know exactly where B is yet. Okay, and we're going to solve this by counting, because every first grader knows how to count. So I'm assuming that you all know how to count also. So how far to the right have I gone from A to get directly below M? 1, 2, 3. I've gone 3 units to the right, because 4 minus 1 is 3. Okay, and how many units vertically have I gone? 7 units vertically. Yes, 1, 2, 3, 4, 5, 6, 7. So I have gone 3 units to the right and 7 units up. To get to the middle, right? So if I want to continue on to the other points, the other end points, I have to do another triangle that has a right distance of 3, because it has to be equal. So if I go 3 units to begin with, I have to go 3 units again. And how many units up? 7 units up. So right now I'm at the point 4, 10, right? That's where M is. And if I went 3 more units to the right, I am adding 3 to 4 in my, what's 3 plus 4? 7, right? So my X value is now 7. I've gone 7 units to the right. And how many units have I gone vertically? I was at 10 at my midpoint, and then I went 7 more units up. So 10 plus 7 is 17. So B, the other endpoint, is at 7, 17. Okay, and we do that by counting. Because it's in the middle, you have to count equally. 3 units to the right, and then 3 units to the right again. 10 units up, and then 10 units up again in order to get to your other end point. Okay, so then our last question is, what is the length of AM? Okay, and there's something fairly complicated called the distance formula, which is that the distance is the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Okay, but please don't write that down. That is way too complicated for your brain. I just want you to be able to do somebody else.
I did that last year.
Yes, last year. And this is this year, and we're all smarter. Okay? We're going to use our buddy Pythagoras and the Pythagorean Theorem, because it is a derivation of your distance formula. Okay? Noticeably, distance squared equals x squared plus y squared. Okay? So x is the distance that you travel in the x direction, right? That's the change in x, x1 minus x2. And y is the change of your y values, y1 minus y2. Okay, so looking over here at our triangle, how much has our x value changed? 3 units, right? We've gone 3 units to the right. So if we were going to do x minus x, we would end up with 3 as the number, okay? Because that's how far we've traveled horizontally. And how far have we traveled vertically? 7 units, right? This is our vertical units from A to M. All you want is from A to M. So plus 7 squared. Okay, so now we have a nice algebraic equation we can solve for D, the distance between these 2 points. So 3 squared is 9. 7 squared is 49, because it's 7 times 7. And 9 plus 49 is 58. Now I have d to the second power, or d squared, equals 58. And algebraically, how do we undo a square? We take its square root. We take its square root. So the distance, and we're going to use our calculator, and we're going to approximate the square root of 58. So when we do that, we get d is approximately 7.616. Okay, so you go to the 4th decimal place, and you use it to round the 3rd one up or down. Okay, so in AP Calculus, when you get there, you're going to want to have 3 decimal place accuracy. So we're going to practice doing 3 decimals in here. 7.616 units, because there's no given units. Okay, so when you have a length, make a triangle, count the horizontal and the vertical. Okay, always positive. Okay, you're always counting a positive direction, whether you're going down or left. Okay, always positives. And then use your calculator to estimate that square root. Okay, so if we have, let's see, what do we have here? Summing up, we have angle postulates, bisectors, and we have some midpoints. Okay, either way you do it, you set up your problem, you make some algebra, you solve for your variable, and then you use that variable to find something out about your picture. Okay, great job. We'll see you next time.